In last class, we have studied hydrogen, lithium, sodium, potassium, rubidium, then cesium, and then francium. These all elements are found in group 1. When we looked at their electronic configuration, we found that these all elements have one valence electron. So from this we can conclude that the elements belonging to a particular group will be having same number of valence electrons. Same number of valence electrons. Then, what is valency? In first class or second class of this science subject, I have told you about valency while explaining chemical reactions and equations chapter. Valence electrons means number of electrons in outermost shell of an atom. So in the elements belonging to group 1, valence electrons number is 1. Then what is valency? For number of valence electrons less than or equal to 4, less than or equal to 4, valency is equal to number of valence electrons. Is it right? If valence electrons number is less than or equal to 4, then valency will be equal to number of valence electrons. What if number of valence electrons is more than 4? if number of valence electrons is more than 4, then valence is equal to 8 minus number of valence electrons. Eight minus number of valence electrons. Because number of valence electrons in the elements belonging to same group is same for a given group. For a given group, valency also remains the same. For a given group or any considered group, valency is same for all the elements. Is same for all the elements. So what are same here? For a given group, number of valence electrons is same and valency is also same. It means that again in this group all elements have same number of valence electrons as well as same valency. Similarly in all these groups. Similarly in all these groups. All elements here will be having same number of valence electrons and same valency. Okay. So same thing is given here. I will just explain. You will find that all these elements contain the same number of valence electrons. That means elements in first group. Similarly, we will find that the elements present in any one group have the same number of valence electrons. That is what I have explained. For example, elements fluorine and chlorine belong to group 17. How many electrons do fluorine and chlorine have in their outermost shell? Hence, we can say that groups in the periodic table signify an identical outer shell electronic configuration. So here what they have asked here, what similarity do you find in their electronic configuration? So answer for that is here. Identical outermost shell configuration is there for all the elements in the same group. On the other hand, the number of shells increases as we go down the group. This we have observed. This we have observed. Here we have observed. We studied hydrogen, lithium, sodium. In a group, all these belong to same group, that is group 1. If I go down in a group, first element has only one shell. Second element has two shells. Third element has three shells. And if we go down further, number of shells will go on increasing by 1. That means next element in the same group will be having 4 shells. So we have to go on adding 1 shell to the number of shells in previous element, to find the number of shells in next shell. That means if any element is here, number of shells in this element will be equal to 3 plus 1, because here 3 shells are there. So 3 shells plus 1, that will become 4 shells. Okay. So this is also very, very important statement here. The number of shells increases as we go down the group. Please underline these sentences. There is an anomaly when it comes to the position of hydrogen, because it can be placed in group 1 or group 17 in the first period. Can you say why? You will see here. We have placed hydrogen in group 1. Now they tell that it can also be placed in group 17. This anomaly was there in Mendeleev's periodic table also. Here what we are having: fluorine, chlorine, bromium, iodine, then acetylene, etc. These all are diatomic in nature. That means fluorine atom will combine with fluorine atom to form F2 molecule. Similarly, chlorine and all these halogens. These are called as what? Halogens. These halogens are diatomic in nature, and also these are non-metals. Similar to this, hydrogen is non-metal, and also it is diatomic. That is, it exists in its free state as H2. But if you see, it is placed in the group of metals. Lithium, sodium, potassium, rubidium, cesium, francium, all these are what? Metals. Non-metal is placed in metals. So this is one anomaly. Because of its nature, it can be placed in group 17, but it is placed in group 1 according to the law of modern periodic table. Because here classification is based on what? Classification is based on atomic numbers. We have to arrange the elements in the ascending order of their atomic numbers. By that rule, it is in first group. But looking at the properties, it should be there in group 17. So this is one more anomaly, right? These all things you have to remember. For this, you can just write one note here. By law of modern periodic table, H is placed in first group. But H is non-metal and diatomic like halogens, like halogens. Therefore, it may also be placed in group 17. Hence, there is anomaly in position of hydrogen. In exam, they may ask why there is anomaly in the position of hydrogen. Explain briefly. Then you have to write it. I hope you all have written this paragraph or point. Okay. This to make O here. This is O, anomaly, not A and A. Next, we'll look at activity 5.5. By answering the questions in activities only we can understand modern periodic table very easily. Don't neglect activities. Don't write only these lines which are not in blue box. You have to read activities, try to answer them, then only you will understand what is modern periodic table. Otherwise not. If you look at the long form of the periodic table, long form, short form, you don't think it that way. For example, BA means Bachelor of Arts. BE means Bachelor of Engineering. That way you don't take long form here. Long form means if you go from left side to right side of the periodic table. What is long form meaning here? If you go from left side to right side of the periodic table. Left to right side. Meaning is that. Otherwise, you will keep on searching for long form of periodic table and you will not get anything. You will find that the elements lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine and neon are present in the second period. Write down their electronic configuration. Now what we have to do, we have to write the electronic configuration of these elements. Shall we do that? Okay. Activity 5.5 lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay. First I will take lithium. I hope we have already written electronic configuration for lithium. What is that? 1s square to s1. 1s square to s1. Now take boron. Take boron. We have to look for atomic numbers, that's all. First, we'll take beryllium, then boron will take. Beryllium. After lithium, we are having what here? Beryllium. What is atomic number 4? Atomic number has increased by 1 from when we have moved from lithium to beryllium. Now we have to see how we fill the subshells. Is it right? How we fill the subshell? When we are having two orbits, 2s square and 2p6 will be having. Now in lithium, 2s1 is there. And now atomic number has increased by 1 or number of electrons has increased by 1. In the next element, that is beryllium, I have to fill first the S subshell. That means 2s1 in beryllium will now become 2s2. 2s2. So 1s square. First orbit is completely filled. And now we will have here 2s square. You take next boron. Boron. What is the atomic number of boron? Refer to periodic table. Boron is here. Atomic number is 5. That means valence. There are 5 electrons in boron. Total number of electrons is 5. Okay. How to fill this? Boron's shells. First shell 2 electrons. Second shell S subshell 2 electrons. 2 plus 2 4. 1 is remaining. 1 electron is remaining. That has to be filled in P subshell of second orbit, because arrow mark goes down like this. After filling 1 S, you have to fill 2 S. After that you have to fill 2 P. Then you have to fill 3 S. So first what you have to fill now? 2 P. But only 1 electron is remaining, so it will become now 2 P1. It will become 2 P1. One S square, 2 S square, 2 P1. Now can you write for next? Carbon elements electronic configuration directly. What is happening here? What is happening here is number of electrons is increasing by 1 in the outermost shell. In the outermost shell, number of electrons is increasing by 1. Second orbit, 1 electron. Second orbit, 2 electron. Second orbit, 2 plus 1, 3 electrons. So now 1s square, 2s square, 2p2, because you have to increase 1 electron. Nitrogen, 1s square, 2s square. Come on, tell me, what should I write here? Are you listening to me or not? Nobody is active. Are you sleeping? Have you gone to bed back? No. Very good. One student is there, P3. Thank you. Oxygen. Tell me what will be the electronic configuration? 1s square, 2s square, 2p4. Very good. Correct. Next we are having fluorine. 1s square, 2s square, 2p5. So 7 electrons are there in its, there are 7 electrons in its outermost orbit, that is second orbit. So when we go from left side to right side of the periodic table, number of valence electrons goes on increasing by 1. Number of valence electrons goes on increasing by 1. That is what we observe here. Okay. Next, do these elements also contain the same number of valence electrons? No. Answer is no for it. Because valence electrons number is increasing by 1 when we go from left side to right side. Do they contain same number of shells? Yes. How many shells are there? How many shells are there in all these elements? One shell, two shell, one shell, two shell, again one shell, two shell. These all elements are having two shells only. It means that all the elements belonging to the same period. Row means what here? Period. Column means group. All the elements belonging to the same period will be having same number of shells in them, but valence electrons number will go on increasing by 1 when we move from left side to right side. So that is what we have to write here. In a period, when we move from left side to right side, number of shells remains same, number of valence electrons increases by 1. So this is what we understand from activity 5.5. So these are nothing but characteristics of modern periodic table. This is what you have to remember. Don't try to remember entire periodic table. Know its characteristic. Okay. Don't try to mug up entire periodic table. You will not prove anything by remembering periodic table. But you will understand chemistry if you remember the characteristics of periodic table. That is very, very important. I hope you have written. So for this activity, explanation is here. Now we will understand why should we do the activity. You will find that these elements do not have the same number of valence electrons, but they contain the same number of shells. This note you have written already. You also observe that the number of valence shell electrons increases by 1 unit. As you go from left to right, what happens? Number of valence electrons increases by 1 unit. That means 1 electron number will increase. When you move from left to right side, same number of shells you will find. There is no increase in the number of shells. As the atomic number increases by 1 unit on moving from left to right in a period. Why there is increase in number of valence electrons? Because atomic number increases by 1 unit on moving from left to right in a period. Is it right? For lithium, beryllium, boron, and so on up to fluorine,